Okay, we are here to talk about incremental language development, and we've got a few functions we're going to look at here. EchoEvaluation. Okay, so this is the new design, another iteration of this design, is that correct?
Yes.
What am I seeing in Notebook here? Is this?
It's the same thing. It's just that we were told that there were problems with today's builds, so we prepared that.
I see. Right. Okay. We can't run in today's builds. Okay. So what is the? So this is what it looks like. So this is the ordinary. Is that space really what happens when I say echo? Oops. Oh, yeah, that space isn't as big, right?
Right.
How come it is as big in this mockup? Is that just a mistake, or is that something that what got changed and is wrong?
That's the design from Billy.
Billy here. That space is wrong. Okay, it should look like this.
Okay.
I mean, this is kind of weird, but I think it's okay, so these are the depths. Is that right? This is the depth. What is that? What is the number there?
That's the depth of EchoEvaluation.
Okay, I think we should go with this, so long as we fix that spacing problem. Okay.
Okay.
Unless anybody objects to it, I think we should go with it. We'll see how we feel about it. It's something we can change later. Make sense?
Yep.
Sounds good.
Notation for leap days and months in new calendars.
Right. So the thing here is that in some calendars, there are days with the same number, but distinguished by the fact that ones are leap, the others are not. And so,
oops, go ahead.
What we have seen in the main reference we are using is that they are distinguished by a Boolean. But that means that most days will have a number which is something comma false.
Oh gosh, that's crazy. All right, let me understand this case.
Yeah. So for example, this happens both for months and for days. So this is an example for months. This is a year in which we have 12 months, but you see, for example, that month 7 is repeated. The first time it's called 7 true with 29 days. The second time is 7 false with 30
days.
Okay,
hold on. So this repeated month exists for what reason?
Yes, so this is a lunisolar calendar, and because a lunar month is shorter than 30 days, then there are years with 13 months.
Okay. So what do they call these months? If somebody was writing out, I mean, they don't say 7 false.
Right. They call it first something, second something.
So they call it the first 7, the second 7.
Right, and they will have some word. I mean, in Hindu, I think they use a word, something like adhika, and that means the second, apparently.
Okay, but if they're writing the date in a document, as we would write, whatever it is, 9/9/20 or something for today. When they do that, what do they write for that 7?
So the 7 will have some name, and then the true or false will be just the name of the month or the month with something like second. For example, this happens also in the Jewish calendar, the Adar month, and they use Adar or Adar 2.
Okay. Do we have somebody who knows? Do we have Itai, somebody who happens to know? Do we have anybody who knows these?
I don't think so.
Okay. Let's see if we can find Itai and Sushma. as samples.
Okay.
Because what I want to know is, for computers, they must have a way to do this, and it's not 7 true, 7 false. There must be, you're filling out a form, there must be a way that those are specified. See what I'm saying?
Yes, yes. So we were thinking of having the month 7, the standard 7 as the 7, and then decorate somehow the second 7 with a
Well, the
head.
question is whether it's a string, whether it goes to a string. Because right now, okay, in all calendars, I mean, if we pick some random, okay, question. Right now, these things are numbers, right?
Hello.
Hi, we have a cultural question for you, Sushma.
Okay.
We have been told that in, what is it, the Hindu calendar?
The Hindu calendars, yes.
Okay, that occasionally there are second month 7s added and things like that. Are you aware of this?
What do you mean by second month 7?
So there are months whose months with the same name. It's just that these are the lunar months, right? And one month is two consecutive names, and I think the second one is called Adhika, or something like that.
So I mean, okay, so there are I should, one second, I'm not in the mode of thinking this, but there are 2 different types of calendar. One is based on the Hindu solar calendar, and one is based on Hindu lunar calendar, and the months might be a little different, not too different, but like, there is a day or 2 off or something like that. So I know what you're talking about, Adhika, but I don't have correct answer for that though.
But so when people use these calendars, do they have computerized forms where you fill out a date from one of these calendars?
What do you mean? No, it is generated every year, and you can't know that before that year starts. This is how it is.
Okay, but I understand that. But when you write a letter or something and you date something, or you write, or it's some, there's some event calendar somewhere and it lists a date.
Right.
What does it say when it's the secondary month 7? What does it say on the I mean, or are these things used in a fairly ceremonial way where things are written out in words?
It's written, it's mostly written out in words, and sometimes, when there are sometimes ambiguity, which we say it is like, you can celebrate anything in both of these days or something like that. Happens quite a bit.
Okay, but if you had to specify this, and you had to specify it in some, like we would write, 9/9/20 for today, right? If you were writing the secondary month 7 in a short way, is there a short way to write it?
I don't know. So
okay, that already tells us something.
I can tell you how usually we see this calendars, right? So we have this months, right, which is equivalent to the months we have in the normal calendar, and then we have these names, which is like Ashwini. It's names, which is equivalent to dates. I see it, and it is not as like the dates are not as consecutive. We would see like, as it is in numbers, that it is not like just 1, 2, 3, 4. It does come one after other, but sometimes it might come 2 days after so if it is like Ashwini, then it will come, the second date might come 2 days after because of the alignment or something like that. That's how.
So wait a minute, that word that you just used, is that a day of the week word, or what is that word?
It's day of, like, it's equivalent to, I would say it is equivalent to 1, 2, 3, 4, like, January 1st or January 2nd, something like that.
Okay, so for example, if you were to give a sequence of that, I mean, just for our cultural understanding, right? Is there a sequence of those words? Like, is there? I mean, what would they be? The sequential words that would be used for this?
I don't I don't remember them because I don't. But I do. I think I do have a calendar somewhere in my house. I can find it out and get back to you guys as soon as possible. If not, I'm definitely sure my brother has one because he follows them more than I do.
So just give us a sense. What are these things used for?
For our festivals, yeah, mostly very prominently used to know when a festival falls on a day or something like that. I know, like in my family in general, we use if we want to do any event on a particular month, say, then which months are um, uh, acceptable months and which are not, which day in the month is acceptable and which are not. So those kind of things we determine using looking at those.
Okay, all right, but I mean, in terms of, look, I mean, the question here is, we are trying to characterize, so we're trying to convert from, Western calendar to Hindu calendar.
Mm-hmm.
And the claim here being made is that you can end up with that there is a second month 7 sometimes that is there because of the misalignment of lunar months, and that you can then end up, your date today, for example, might be in the second month 7, and the question is how we represent that.
I see. Do you mind if I come back to you probably in a day or so with?
Yeah, that's fine.
I
think okay. So the answer is it's not obvious. That's the first question, and it sounds like we have to check with some other people. I mean, I think it gets much wilder than this. I think I was mentioning, Christopher is trying to do this work on some Babylonian historical thing, and there, random months were added just by the edict of some king back, 2,500 years ago, and so on. So how are we going to deal with all of this? I mean, the basic point is that month names. All right, yeah, Sushma, I think that's probably everything that we can get from you right now.
Yes.
But yes, let I guess it's Nick and Jose know what you figure out.
Okay.
Mm-hmm.
Yep.
That'd be great.
Yeah. Thank you, Sushma.
Yeah, thanks, Sushma.
Bye.
Yeah, so in this case, something can be done because this is computed from the position of the sun and the moon. So that's why they compute it every year, because they are waiting to know exactly the data. But we have good predictions for that. Now, of course, the historical data of what some king did thousands of years ago, that has to be tabulated. There is no other way.
Right, I understand. Apparently, I mean, Christopher was looking at the thing for the Babylonian, whatever it is. Apparently, that is, you get it from random scraps of some random inscription says this or that. Mm-hmm. And occasionally the scholarship changes, and you have to. That's an important point for this historical stuff. Occasionally the scholarship changes, and then you've got, this revision of, it's like the human genome. It's got a revision number effectively.
We do have the Babylonian calendar, right, Nick?
Yeah, we have an astronomical Babylonian calendar. So it doesn't have tabulation from historical changes, but it has.
Somebody should send mail to Christopher and ask him about this, because he is literally just trying to do. I mean, he has some quite elaborate calendar thing that I think is way. I mean, again, in these times, right? They have these regnal dates, which are based on, the reign of such and such a king. I mean, don't they? Doesn't Japan still use something like that?
Yeah. The formal calendar in Japan is still a regnal calendar. It basically follows a Gregorian calendar these days. In the far past, it was a lunar calendar. But it basically, the year that it is like currently it's like, I think Heisei, like 30 maybe. It's like the 30th year of the current emperor's reign. And whenever the emperor passes away, that's the last year of that reign. And it's the first year also of the next person's reign. So like 1999 was the 84th year of Showa and also the first year of Heisei. And they'd switch on January 4th or something like that. So you basically have this big table of when imperial reigns end, and you kind of have an era marker that says this is so-and-so's reign, and it's the nth year of it.
All right, so look, one point about this is, okay, so there's more complicated structures than just a number, is the basic point. The designation of a year or a month or a day can be more complicated than just a number. So the question is, what is that more general structure? And I would argue that we can do better than the true-false thing. And one question is whether those things, I mean, we don't want them to be pure strings. You know, we could say 7A, 7B or something, but I think that's not very good. We want it to be as computable as possible. But, okay, so the basic point would be, okay, so there's an argument that in these cases, we should have a full form that is some kind of association that says, you know, like in the Japanese case you're describing, it's an association that says emperor arrow. And then that emperor, because who knows, there might have been two, there were how many people named Cleopatra who were, the queens in Egypt? Who knows? I mean, right? So, but we do have entities for those people. So there's an argument that when we're dealing with these things, that what we do is we simply have an association that says, emperor arrow, and then we have an actual entity for that person, and then whatever it is, regnal year arrow 17 or something, right? That we go ahead.
I'm not sure. I mean, what we have is a list of different granularities. That's fixed. And so I think what we need to do here is that granularities are not necessarily identified by numbers. We allow strings in the regnal case, in the geological periods case, etc. And in this case, we need a variation on numbers. It's a small variation because we just need additional bit. So perhaps just by wrapping them with leap, the word leap, or
no, it's not going to be general enough. No, I mean the thing I'm claiming is, once you go out of, it's just a numbered month and it's a numbered day, right? I claim that all bets are off. It could get arbitrarily complicated.
Yes, but it would still be the numbering of a day. It's just a very weird numbering.
Yes, I agree. But what I'm proposing is that number, basically, in its full form, which could be elided, its full form becomes an association. That, for example, in the case of regnal calendars, literally gives association, name of emperor. I mean, rather than trying to stuff it in a list where we say list, emperor, comma, year, comma, comma, integer for the year. Why am I suggesting this? Maybe I'm wrong. Maybe each one of these. Okay, so there's two approaches. One is, the point is it's somewhat self-documenting then what it means. If you see some random date from, ancient Phoenicia, if we even have, Phoenician, if we even know enough about the Phoenicians to know that. But let's say, Phoenician date with totally wacky things in it that we are quite unfamiliar today, right? We at least have a fighting chance of representing those. And for example, the whole thing about, authority, that is in the case of, in the case of Babylonia, right? There are, you could say the authority that says this is a date, what this date is so-and-so, and that maps into this. But if we have an association, you can have all of that information.
Right. So I think a good place to put additional information is calendar data. So for example, what we have right now is calendar data of a calendar, granularities. We list the different granularities. And for the Japanese calendar, the first one could be regnal era, and the second year, the third month. And so there you see the meaning of all these positional elements.
Oh boy. Okay, so what you're suggesting is, I see, what you're suggesting is that we treat everything as mixed radix, basically.
Exactly. Yes.
With positional elements. I mean, I don't know, does every calendar, okay, so you're saying that every calendar worthy of the name calendar has this notion of granularities that operate like mixed radices.
Exactly. It's just that the actual identification of a day, for example, may be very complicated. The Aztec and Mayan calendars changed every day 2 numbers. So we have to pair those 2 numbers in a pair, and those 2 are the day identification.
But so then how do we tell, given 2 days in the Aztec Mayan calendar, how do we tell which one was after which one? That might be a non-trivial test, right?
Correct. I mean, we would have to, do subtraction of days.
Right, but in the case of regnal calendars,
Mm-hmm.
we have to go look in a table, basically.
Exactly, yes. I mean, we still can do less, and that will figure out everything.
Right, but I mean, we have to have, right, so our less than would then go and look up properties of random kings of Babylon type thing.
Correct.
Okay, weird world. Okay.
Mm-hmm.
So what you're suggesting is, you say you don't believe in my idea of each of these elements becomes an association. You say that we define these positional elements, and then within each positional element, what happens? We say each one, there has to be some other aspect of the calendar data which gives essentially the pattern for what those for what occurs at element such and such of the Aztec calendar, for example. Is that right?
Right. So for example, imagine that we have some weird granularity whose duration is 200 days. So calendar data will know that and will be able to report that. So calendar data is a place where we put everything that's known or needed to be known about the calendar.
Okay, but for example, the cycle of the whatever is it, the Mayan calendar, which ended in whatever it was, 2012 or something, I forget when, where
Yes.
the big giant cycle ended then. But we can't, right now we have in data object, we have a specification for granularities, right? We're not going to document here, if we look at the granularities, right? Century, et cetera, et cetera, et cetera. We're not going to have some wacky thing in this table that says, as Mayan long year, whatever the long form wraparound time, are we?
No, we're not. So here we have the 6 basic granularities of the Gregorian calendar plus extended notions of granularity that are implementable in that calendar too. So what we will do is document all those other things in calendar data. So each calendar will have its own set of granularities.
I see. Okay. So you can't ask for the Mayan long form granularity of our
Gregorian, no.
Okay, you have to convert to Mayan, and then you have a Mayan data object, and then you can ask to add one. Are those in the units as well?
Yep. Yeah. So all of the Mayan long count steps are in units. So the Mayan long count calendar uses base 12 steps. And if you say, I think like there's a unit of Mayan tune is something on the order of close to a year. But again, there's not a mapping from year to the Mayan long count step because it uses a different base value.
Gigafact on our live stream is asking, is there any real use to supporting these old calendars? It's history is valuable. Like, for example, the 700 years of astronomical observations made by the Babylonians allows us to answer, all kinds of questions, so long as we can know when a particular observation was made. In the theory that history is worth remembering, it's worth getting right once and for all of these calendar issues. And then we just don't have to think about it again. Every random inscription found in wherever that has a date on it, we can say when that actually was. That's the point. Brian is mentioning the French Revolutionary Calendar, which I know had absolutely crazy stuff in it. Although I don't think it was as crazy as some of these other ones.
Yeah, there's 2 versions of the French Revolutionary Calendar too. There's a strictly astronomical one, and there's an arithmetic derivation of it, and we have both.
Oh,
like
boy.
they're 10-day weeks and other things like that.
Brilliant.
Months of 3 weeks of 10 days.
Okay. Who invented that stuff anyway? It's probably somebody we've heard of.
Yeah, it was a big secular push. It was that was the 10-day week motivation, was to move away from a religious basis for the
Oh, that
week.
was viewed as a biblical 7 days or something? Huh.
Apparently people didn't like it because they had to work 9 days instead of 6 per week.
Yeah, right. Okay, so anyway, so what you're proposing, we should get this information from Sushma and others. I recommend you ask Christopher about his Babylonian thing, because I think that's, again, a very, very squiggly, complicated case. But you're fundamentally saying that in calendar data, what we would record is the list of what would it be? So you're saying you would give a pattern for what every date object would have in it. That is, it would have. Go ahead.
Sorry, I would say calendar data of the name of the calendar, granularities. So calendar data becomes a property value. Entity value, entity property, table. And so we have calendar data of the calendar, granularities gives the list of the granularities for the identification of an instant, even.
Okay, so hold on. So this calendar data of Mayan. Oh wow, what does that do? Oh, that's just giving. What the heck is that?
Can you explain, Nick?
Yeah, this is the current version of calendar data specifically set up for holiday calendars, which is something we talked in the last meeting about changing, because it basically lists the schedules available. And so we're working with the Alpha team too on synchronizing that with Alpha's curation of holidays and setting up a proper holiday data or holiday calendar data.
Fine. But this is basically stock market holidays and stuff like that.
Yep. Yeah. So that's a list of exchanges, and default means national holidays.
Horrifying. Okay. All right. Okay. So your proposal is that this becomes what?
So the entities will be the calendars, and then we will have all sorts of properties about the calendars. The epoch, when do they start, the granularities.
Okay, so the granularities will be what? Will be a list of the mixed radix granularities. That is, for our calendar, it would be year, month, day. Is that right?
Exactly. Yep. Hour, minute, second.
Okay. So, but that does not allow. So, week, for example, is not in here.
Exactly. So we distinguish what we call the granularities or native granularities, which are the ones you have to use to actually represent a date, from the extended granularities, where you include everything, weeks, millennia, whatever.
I see. So instant would not occur here. This would just be hour, minute, second.
Exactly.
Okay. So these are base granularities, basically.
Yep.
That are used to actually define the meaning of a moment, of an instant.
Exactly.
And then there are the, what are we calling them, extended or something like that, granularities, which are things like week, which are simply, so those are not units, because these granularities could be something which changes time over the course of, in other words, it's not a fixed, it's not a unit, am I correct about that?
Yes, extended granularities will still return a list of strings. Then we have a separate property called granularity quantities, something like that, that gives you an average quantity, so that you get an idea of the size.
Okay.
For year, month, everything. And if there is a unit that represents that, like we have the quantity years, then we return, of course, that one.
Okay. So look, I'm just not, so for these things here, what defines the structure of, so for example, one of these base granularities could be, regnal period or something, whatever it's called. Is that right? For some other, is that right? I mean,
Yes.
Yeah. So if we use the Japanese calendar as an example again, you typically talk about eras. So people talk about the Heisei era or the Showa era as sort
Okay,
of
so era then would be the first. So in that calendar, the first thing would be era. And what tells us what kind of a thing can be filled in there? Is there a property of that calendar that would tell us what the possible values for era are?
That's a good point. We don't have that yet, but we could, certainly, right?
Yeah.
And we probably should have that for these cases where it's a random list of emperors or something. We probably should have the list of emperors. Otherwise, it's not clear how you would get it.
But we have another property called granularity ranges. So for example, for numeric cases, we say month goes from 1 to 31. So we could have for strings, we could have some sort of enumeration of all we support.
I think that would be a decent idea.
Yeah, I think so.
Okay. Wow. Yeah, more cans of worms. Time is complicated. Sandra has suggested saying, why don't we just number the days 1 through 365? People do have numbered day systems.
Yeah, the ISO ordinal calendar does that too.
The problem is that there are 365.2481. Am I remembering correctly? 26 or something?
Yeah, 249 something.
Right. Days in the year. And that throws everything off. And that number changes as the Earth's rotation period changes as a result of random, activity in the mantle and things.
We actually have an interesting calendar, which currently is called Rata Die, it's Latin, which is the counting of days since January 1st of year 1. So we are now about 790,000 days.
Well, but it's pretty common in astronomy, right? The Basilian years and things like that, which are
exactly Julian dates, yeah.
Right. Relative to what? There's a bunch relative to January 0th, 1900, and there are a bunch. Yeah, but by the way, what do we do with the lack of a year 0?
So there's a parameter for it in calendars. Some calendars by default include a year 0, some do not. We made all of the calendars parameterizable. So if you want a Gregorian calendar that has a year 0, our default does not have one. You can basically specify that as part of the calendar specification.
Right. But by the way, in your enumeration thing, there is dependent enumeration, right? I mean, you might have some weeks, for example, might have some named days, but another week might not have the same named days. So when you talk about an enumeration of the value of some granularity, that presumably is the superset enumeration. See what I'm saying? In other words, it could be that a higher granularity constrains the enumeration of the lower granularity. Right? If a particular year has an incomplete month, such and such month, or no such and such month, then if you listed out these are the possible months, that would not be correct for some particular year.
Right. Yeah, we definitely want to go with the superset for enumerating them.
So it's the same thing when we say ranges of months, we say 1 to 31. We don't say, oh, it depends on the month.
Fine. You know what? In those ranges, are you? Oh gosh, I mean, I think an enumeration is going to be more useful. But then you have these things like, they're an infinite number of years into the future type thing. So that's the only case that I can see where you can't enumerate. Like days of the year, days of the whatever, those are all enumerable. The only one that isn't is years.
Right. The first one typically is unbounded because you have to consider the whole axis.
Yes.
Yes. So for that, we are returning minus infinity to plus infinity.
As a range. Then the other ones, but when you give a range, does the range necessarily, is it sort of, densely in some sense of integers filled? Well, in some sense, there are, like for seconds, what do you give there? Do you give 0 to 60?
Yes. Actually,
so
0
it's like,
to 59.
how can it be to 59? Can't you give seconds in 59.972 or something? How can it be right that it's 0 to 59 for seconds?
Yes, sorry, you're right. So for example, for months is 1 to 12. But for seconds is 0 to 60. Yes, you're correct.
Okay, but how do we know which one is integers, which one is real numbers?
That we don't mark yet. We could have a type.
Mm-hmm. So hold on a second. In what we've done for coordinate systems, we've had this issue for coordinate systems. What are the possible values in, parabolic cylindrical coordinates or something?
Right.
How do we deal with it there?
Well, in those cases, it's always reals. So we just enumerate the ranges. We have a range property. So angles go from 0 to 2 pi and things like that.
And wherever possible, we try and have a normalization scheme where, if you say this is day 2.4, we can then normalize that down to a number of hours, minutes, and seconds, where we can standardize that a day value on a Gregorian calendar will always be an integer value. And if there's a fractional remainder, then it gets populated to hours, minutes, and seconds as necessary.
Right.
In the same way, I could say the 31st month of this year, we'll say, well, that's, so many months after December. And so we increase the year value by 3 and then continue running on, or 2.
All right. This is a complicated can of worms. But so it seems like we need to have a more complete story of how this is all going to work. We can't answer this specific question on its own.
Okay.
All right, quick look at some of these other things.
Yeah, so next we have 3 functions you suggested. And
is this function interesting?
For use in same test, I think it could be interesting.
I see, that's its primary use. Does it raise to the level of, the problem is that it suggests it's so much about mod and modular arithmetic, which it is not.
Or polynomial algebra, which also it is not.
But essentially, it's a by wrapper. It turns same test into a by test. Is that correct?
I think so. Some sort of same test by.
Right. Well, that's an alternative approach, is to put an option same test by.
Well, we would need, say same test is what says whether we want equal or same Q. It's just that we want to intercept that with an additional function.
Yeah, we use same test in a few other places and ways. The typical thing one would do now is to incorporate the F into the same test explicitly.
Right, but the problem is that the same test is a binary operator, right? The issue is it's the difference between sort, which takes a binary, function P, which takes X and Y here, right? And sort by, which takes a unary valuation function, right?
Right.
And same test currently, wherever we use same test, it is expecting a binary test function. And so this is something which goes from a binary test function which we can put in place of the binary test function to turn it into a by function.
So yeah, all I'm saying is with elaborate coding, one can use same test already.
Obviously.
We shouldn't have this.
Right, obviously. I mean, obviously you can just write same test same Q F of #1, F of #2.
Yeah, which is, people sometimes do.
Right. I mean, this is more of a conceptual thing. And I mean, the alternative approach would be to have a same test by option. What functions have a same test option?
We can ask Wolfram language later.
Union, complement, intersection are some. There may be others. I'm not sure.
Right. But I mean, we don't have a union by function.
Right. Nor do we particularly want one.
No, we don't. But this is an attempt to generalize that situation where we do have a same test. I mean, what would the more same by? I don't know.
To me, the problem here is that we still need to specify same Q. So we still need the two arguments. So this would work like same test goes to modulo equivalent F comma same Q.
Yeah, it's not really helping much.
It's same size of what you wrote.
Well, let's try putting something with as good a name as we can to the function repository. And then we'll be reviewing it later. Yeah, this seems useful. Detrend, delete a linear trend. And possibly it could be generalized to fancier trends.
No argument there, but I'd like to push back a little on it being an ILD function.
Well, I admit that the statistics team could be the one to do this.
I think they should be. The reason is they're more likely to get it right.
Fine. Talk to them about it. Okay.
I'm willing to guess that there are several options and default settings and tuning things that go into.
Oh, I agree completely about outliers and all that kind of stuff. I just think it's a useful function to have. I mean, it's something.
No, unquestionably.
Fine.
Yeah, I think it goes along standardized, for example, things like that.
Yes, I agree. Who wrote standardized? Was it the machine learning team?
I don't know.
I think it was.
That might go all the way back to Anton Antonov, or Rescale might. I'm not sure.
This one is, gosh, this is surprisingly old, standardized. Okay. All right. In any case, go talk to those people, figure out what can be done. Okay. Actually, Gigafact is asking the reasonable question: how many calendars do we support right now? Can we display today's date in every calendar? Do we have a way to do that?
We can. In 12.2 currently, there are only 4 calendars. Right now, in the branch that we're polishing up for 12.2, there are 40.
Okay, so it's going to get much more interesting.
Yeah, there's lots of possible permutations from there too. Of they're different astronomical Baha'i calendars depending on where your reference location is, which is a parameter. So there's yeah. But
okay, so we can't do anything exciting with that yet. Steve is asking, is there a reason why we always use the system clock and we do not independently pull from NTP? I think we try to rely on the fact that we're correcting for speed of light or for transmission times, which I assume the system clock, I don't even know how that works now that I think about it. When you synchronize your system clock from the NNTP server, does it correct for your ping time to the NNTP server?
That I don't know, but I would expect that it's the responsibility of the computer to do those things, not us.
No, I agree. I agree. But the question is, do we have a way? It will be interesting if we had a way to query the NNTP server to ask what it thinks the time is. What is that thing called? What is that thing? The thing that's in Colorado somewhere. Right. So I mean this fine thing.
Mm-hmm.
Pretty scary that yeah, anyway.
So you're saying that the computer is not doing this? So for example, when there is a leap second, are not the computers getting informed via this?
Yes, I think they are, because there's a daemon running in your computer that I think is querying this thing.
Exactly.
Yeah, I think that stuff is generally pretty well scheduled by operating system developers, where it knows in advance when a leap second is coming in, because
right, it's agreed in advance. Right.
Yeah, and there's some place, places like Google tend to do things with leap seconds, like smearing them across a day, where there's a fractional increase in time spread throughout the day rather than dealing with the leap second at once. But generally, we rely on the operating system for that sort of timekeeping. But there are other factors, like how you handle leap seconds when there's different time systems, which is something that we've been discussing in some detail for future development. And it's probably not something Jose wants to go into right now,
right.
But there's a lot involved.
Right. No, I mean, we know that for the astronomy stuff, it matters. Many details of this matter. It's somehow a little bit scary that at the end of the how does one know time on the internet? At the end of it, there's a what is that? A bear with a birthday cake? Anyway.
Maybe a top hat?
I don't know. Oh yes, it may be a hat. Oh yes, it is. It's a clown bear with a hat or something. No, I don't know what this is. I'm not culturally aware. All right, let's look at these other things. Pattern form. What is this? Yes, the idea of this is, imagine you have a pattern. Imagine you have something where whenever you match this, okay, let's say it's this, something like that. That means you're looking for something which matches blank blank, but for purposes of the pattern binding system, treat that as 78.
I see.
What in honk all are you saying?
I'm saying, if I say f of this, right, colon equals x squared, then I'm saying that f of AA would now turn into, the x would bind to 78. Is that crazy?
Only if you want it implemented.
So this is the sort of thing we would do with if match Q, do this.
Exactly. Yes. Right. It's a way of cleaning that up.
Mm-hmm.
I don't think it's so stupid. And I also don't think it's that horrendous to implement. Because as far as the pattern matcher is concerned, it just looks like blank blank. What this is doing is simply it's giving you, it's starting to fill the pattern. Okay, so then you might ask this question. Okay, so then it gets a little wilder if you say something like this, right? What does that do now? If you say f of x colon blank blank, comma x blank, colon equals, let's say, x here, okay? Now I say f of 3, comma,
I think you need the same one.
I need the same one, right? So that matches, but this and this will match as well, but
No.
This.
No, as soon as you change something, it doesn't match. So the double X is requiring.
Oh, no,
that
yeah,
both...
right. I know it has to be both the same thing.
Exactly.
So, but if this was 3, 4, 5, even though the X's are the same, one of those X's doesn't bind, and so it doesn't match. So in this case here, this would only match if the X blank here, if I fed in F of
78.
No, that's not good. No, it will be F of AA, comma 78. Right? Then it would match.
Mm-hmm.
I don't think this is a stupid construct. And by the way, another class of constructs we need to start talking about are the two-way pattern rule constructs. Because as we get more and more into theorem proving and into all these systems where we can have basically patterns on both sides of the expression, which is what we've implicitly done for years. In I mean, this is relevant to axiomatic theory, and it's relevant to turning axiomatic theory into pattern variables. But it involves patterns on both sides of an expression. It's something, as I say, algebraically, we've done that for years. When we say, some random polynomial equals some other random polynomial, the x's on the two sides are effectively pattern variables that we're then, for example, solving for.
So we had discussed two-way rule with two literals, but with patterns, that
we haven't discussed it. Yeah.
I will raise a philosophical and a practical objection. Philosophically, this is a more restricted world and probably belongs in one as a different sort of area of functionality. The practical matter is our pattern matching code is difficult to build on top of. It just is. It's hard to modularize. I think Ivan made a pretty good faith effort, but you've got stuff that has to deal with compiled functionality versus or packed.
Yeah, I know. Look, I wrote the original pattern matcher, and sadly, much of that code is still there.
Well, unsadly, much of it isn't. Did I not say that politely? But
okay.
The fact is, it is still not the most modular code.
I know, it's complicated.
That it is, it just gives us a multiple maintenance problem.
No, I understand it's complicated. And it was, I mean, the good news about it is that it is code that makes many judgment calls, breaks into many, many cases. And yes, that's the good news because that allows for a lot of optimization. The bad news is those things are not particularly modular.
Right, and there is a multiplicity of terms of maintenance because of all the cases. And if we try to put another structure on top of that, one that
I understand. Look, I think it needs to be rewritten. I mean, at some point, and perhaps the only thing to understand is what is the value to doing that rewriting. Part of the value is that if we have an inventory of new constructs that we can put in that have that are powerful, that's a motivation to do the rewrite.
Well, but again, I'm not convinced that this belongs in that world. It's just not as it's sort of more focused. It's more general than say symbolic algebra.
Are we I'm sorry, we're talking about the two-way rules. We're not talking about
two-way rules anymore. Two-way rules.
Okay. Yes, I agree. I'm not sure it belongs in that world either. I mean, it could be right. There's things like pattern unification that are needed there. A good example, my new function, find replace path, that given a set of rules and given a starting point and ending point, it will tell you what the shortest path by using those rules to get from the starting point to the ending point is. Right? Now, if those are one-way rules, well and good, but one can imagine perfectly interesting cases to do with axiomatic theories and things where those are two-way rules.
But two-way rules with literals are just equivalent of A goes to B, B goes to A, which is very, very nice notation for swapping.
It's
If
sort
we
of
have
a
patterns-
hysteresis property you're talking about, where you have to go backwards in some places.
What are you saying?
You're talking about something like a hysteresis property, I think, where you have to go backwards in order to get from A to B. You have to use both directions.
Well, maybe, but I mean, I'm not sure whether you have to use both directions, but it's convenient to enter these rules in a two-way form with pattern variables on both sides. In other words, this is equivalent to saying, let's say that this says G of X blank, okay? We could enter that, and possibly this is the way to do it. F of X blank goes to G of XX together with the rule, G of X blank, X blank. I'm just saying that syntactically and practically, this isn't the best thing. And there are things you can do, I think, with two-way rules, particularly with pattern unification, that you cannot do with one-way rules.
But here we see immediately that the first thing we need is a way of going from an expression that has patterns to an expression that doesn't have them. And there we will find the questions of what do we do with conditions, with modules, all those things.
Yeah, right. So a good example is this recent work on there exists in axiomatic systems, where there exists when it is on the right-hand side becomes a module. Yeah, I mean, this requires more thought. No question, this requires more thought.
Yeah, I think this could perhaps be implemented using pattern matching, but I don't see it as part of the pattern matching world itself.
You're probably right. You're probably right.
Specialized and highly sophisticated.
Well, you're highly right. You're right, so long as the methods that are essentially automated theorem proving methods don't end up informing the pattern matcher in some way, which I don't know for certain that they do not.
Don't end up what?
Informing how the pattern matcher works. That is that, adding some completion or something is a way to speed up the pattern matcher. I don't know that for sure. Haven't thought about it enough to know.
There might be special cases where it can.
Right. But I mean, the pattern matcher is a story of special cases. The specification
I guess what I'm getting at
implementation is quite special.
This axiom and theorem proving stuff is and Knuth-Bendix type completion, I think, is intrinsically sort of like dynamic programming, backtracking, etc., unavoidably so. And so I don't think it's going to, in general, give any improvement on the pattern matcher.
Except when it has to do backtracking.
Well, the pattern matcher is doing that already. The only thing this might have an advantage with is doing it better.
That's what I mean. Right.
Oh, okay.
Yeah, that's what I mean. Because the pattern matcher does it, without, not completely stupidly, but in the case where it has dramatic backtracking to do, it's not, it's using comparatively straightforward algorithms to do that.
Yes, I think though what you're opening a pretty big can of snakelets, because that it's like with almost anything that we overhaul. When you start digging into it, you find that the new code invariably has weak spots also.
Sure.
And it's going to, I'm not saying it shouldn't be done. I'm saying
no, it's a big project. No question, it's a big project. But I think what we need to do is start collecting things like pattern form that are things that we should consider adding to the pattern matcher, that essentially justify thinking about an overhaul. And the two-way rules, unification, completions, etc. Okay, just a very quick, and then we need to wrap here. Yeah, there's a lot of good things here, a lot of good things. Although birds say, as it is not going to make it as a system function.
No, we specifically said that would be.
I know. I'm joking.
Yeah.
this what is it called, kakapo or something, creature that's
So
yes.
Danny, do you remember the criterion to sort this list? So these are the 20 best functions in some order.
These were 20 culled from the top, the 50 most downloaded, as best I recall.
Well, some of these are
yes. Oh, and many we are not proposing as standalone functions, but as possible
features of other things,
options or additions to existing. Import PGN would simply be a new flavor for import.
Yeah.
For example.
All right. Okay. Let's. We're not going to get to this today, obviously. This one really does seem very worthwhile. This one is like some version of this really does seem worthwhile. But perhaps this is purely automatic in map and other functions, that this just happens if they've been taking a while. That would be my preference. And I mean, the progress monitoring framework, which we are planning for 12.2, is the first step in doing these things, although it is not being brought in automatically in functions like map.
Well, I mean, what we're proposing here is that the person or persons working on that at least have a look at these WFR functions to see whether they fit in, whether maybe there should be a second framework for explicit cases, dynamic map, etc. We're not really sure.
Okay, fine. Well, make sure they get that then.
Who are the they, by the way?
That'd be me and Itai and Julio.
I'm sorry, who was speaking?
Devin.
Devin, okay, thanks.
Okay, all right. Thanks a lot, guys. All right, got to go. And I think we're doing another live stream in the top of the next hour. So see you all there. Thanks for